Hello students, once again welcome to Bholanathacademy. In this video students, we are going to see the problem based on chemical kinetics question 9. In question 9 students, the rate of the reaction where A combines with B and it will give the product P is 3.6 into 10 raised to minus 2 mole per dm cube per second. So here students, the rate of the reactions that we are showing with capital R, that is given to you, rate of the reaction is given to you, that is 3.6 into 10 raised to minus 2 mole per dm cube per second. So value of rate of reaction is given when concentration, students, this symbol is called concentration of A equals 0.2 moles per dm cube and concentration of B is 0.1 mole per dm cube. You have to calculate the rate constant. Students, you are going to calculate the rate constant. Rate constant we are going to show with K. You have to calculate the K value. If the reaction is first order, students, here some condition is given, first order in A and second order in B. Okay students, so here order of the reaction is also already given, students, first order in A and second order in B. So here students, first you see the reaction. The reaction here you have two reactant A and B. So we have to apply the rate constant, rate law. If you apply the rate law only, then only you are going to find the rate constant, students. That is why we are going to apply first rate law to this reactant. So here students, you have got two reactant A and B. When you apply the rate law to this reactant, students, so what happens, students, the rate capital R, which is equals to, it is the product of the rate constant and the concentration of A and concentration of B. Rate is equals to what? Concentration of A, it is the product of the concentration of A and the concentration of B. Here students, the power of concentration of A we are going to, in general we are taking X, and this is the experimentally determined value. The power concentration of A power we are going to represent with X, and concentration of B and its power we are going to represent Y. So with the help of the experimentally determined value, these X and Y we have taken in general. We have applied the rate law to these two reactant. Okay students, now students, when you see, you have to find the rate constant. We are going to calculate rate constant. Okay students, what else is given, students? Here the first order, that means value of X is given, that is 1, and the second order, that is the concentration of. So students, from here students, you can see the rate is also equals to K. The concentration of A is how much it is given, that you can put, that is 0.2, and concentration of B it is given, students, that is 0.1. Okay students, and its order also it is given, students. Order is first order of A and second order, that is B. So here you have got from given all the things you have got from the question, students, as per question. Now since students R is also given, capital R, that I already, you want to find K, that is rate constant. So here students, K will be, which is equals to, you have to divide the rate with 0.2 raised to 1 into 0.1 raised to 2. Okay students, now just put the value, students, once again. If you put, rate is given to you, that is 3.6 into 10 raised to minus 2 mole per dm cube per second. Okay students, you have to divide with concentration, that is here students 0.2 mole. Concentration of A is given 0.2 mole. Okay students, unit is mole per dm cube into 0.1 into 0.1 will be, students, 0.01 whole square, students. It will becomes mole square and dm raised to minus 6. Okay students, so this way, students, you have to put the, because if you want to find the dimensions, that means unit of rate constants, so you have to put the unit also. Now what happens, similar unit will cancel, students, mole will cancel with mole, dm cube cancel with dm cube. Okay students, now what happens, students, you have to, there is a simple decimal division, that is rate constant equals to 3.6, only second inverse is remaining in numerator. You have to divide with 0.2 into 0.01 can be written as, here students, it is also given 10 raised to minus 2, 3.6 into 10 raised to minus 2. Now this 0.1 can be written as 10 raised to minus 2 and mole square dm cube raised to minus 6. Okay students, now what happens, students, is similar, 10 raised to minus will cancel with 10 raised to minus 2. Now what is remaining, students, here 3.6, if you divide 0.2, so it is nothing but, students, if you multiply 10 in numerator and 10 in denominator, decimal will go away, so 36 second inverse upon 2 into mole square dm cube raised to minus 6. Now what happens, students? 2 ones are 2 18s are, that is 36. So now you got the answer, students, that is 18. This mole will come in numerator, it will becomes mole per mole square, and dm cube will come in numerator, it will becomes dm cube raised to 6, and second will be second inverse as it is. So this is the value of the k, students, that is rate constant, and this is the unit. This will be the unit of the rate constant. Okay, students. So this way, students, you have got the answers. This way, students, you have got rate constant, that is 18 per mole square dm cube per second. This is very simple, students. For 2 marks question, they will ask an examination, students. If you like my video, please share it, subscribe it. Thank you very much. Have a nice day. God bless you.